What chapter is it?
Perfect. Okay, section 5.1. All right, on this property sheet that you guys have, if you're on the second page, I think it says cheat sheet at the top. You need to look over here. Yeah, you need to look on this side over here. And now, if you don't have your property sheet, this is something you could write down. These are the ones we're going to look at today. Let me zoom out here a little bit. I need to get this bottom row. There we go. All right, these are the ones we're going to look at today. I know this is going to seem a little silly. We're going to start focusing on what they call the Trig Identities today. And these are the ones you need to have in your either in your notes or on your cheat sheet. You need to put a box around it. Okay, we're going to try to do this every section we go into.
How far down?
Through the evens and odds. So you want to go through those. You need to put a box around it. Every section we go into will focus on certain ones. Like the first section or two will focus on these top three categories. There's going to be a little bit of this today. I'll kind of throw this in there just so you kind of know what this is. What these are, just so you know, because we're moving into chapter 5, is these are things you can substitute in on either a calculator or on actual work that mean the same answer. It's kind of like the idea of like a co-function, right? A co-function, you could type something in, it would give you the exact same answer on a calculator. Well, these are the same thing. These are items you can use that would actually perfectly substitute and give you an answer on a calculator. So one of the things I never really discussed was how do you do the trig functions on a calculator, like the reciprocal ones? Like, how do I type in the cosecant of 30 degrees? Like, even though like we could do the special triangles and you could get that exact answer, how do you type it in a calculator? Like if they just wanted a decimal for it. Well, these are the things you could do to type it in, and these are the things we're going to talk about today that you could substitute. There's certain ones you just have to have kind of memorized or have them marked on your property sheet to use them. But I'm going to try to explain today why they work. Okay, so we're really gonna focus on these top few categories here. If we have a little bit of time today, we're gonna venture into the Pythagorean Identities, which is based on Pythagorean theorem. And then, I think there's one or two examples I have picked out today. I don't know if we'll get to them, where we're gonna use evens and odds, which is based on symmetry. And these to understand them really require that you actually have to draw that wave graph to understand it. But I don't know if we're going to get to it today. If we do, we're only going to do like one or two of them. We're not going to do all of them, just so you can see it. But the goal today is to learn how to simplify math problems. This is something that most calc students still struggle with. It's the thing where, you know, like on a entrance math exam for like Iowa State or a major university, they have you take a math placement test. Okay, it's just this little test. You're not allowed to use a calculator. You're not allowed to use anything else in front of you. It's hard, and they want to see what level you're at currently. That's all it is. It's just a gauge. If they do well, then they put you in the class that's appropriate to you, and it saves you money in the long run because you won't have to take all these like extra classes that build you up to the class you would be in later. Okay. What most students always fail at, or what they always do poorly on, is this stuff, which is kind of like the weird in-between between trig and calculus, okay? It's that weird mix where it's simple stuff that you should learn, but you have to learn how to apply it and do it quickly so that you can get to your final answer. And all it is just basic substitution work. You're going to take some complicated math formula, substitute parts in that are of equal value, and it simplifies your problem down to a simple answer. That's all it does. So you can get down to a single answer that's easy to type in your calculator. Because obviously, like if we go to something really complicated, like let me put an example of what I'm talking about here. I just had a bunch written down here. So if we had something like this today, this is like one of the last problems if we even get there today. I'm not expecting to, but. This. It's a long a rational expression that has trig functions in it, right? There's fractions involved, and the goal is to simplify this thing down because this is really difficult to type in a calculator correctly. You have to use a lot of parentheses. Some calculators won't even be able to do that. Like, sorry to pick on you there, Dalton, but your calculator, like right now, the Casio would probably have a heart attack trying to type that. Just because
You put some calculus in there, you're good to go.
yeah, you have to use a lot of them. Like
Kind of amazing.
kind of it's almost too many parentheses in there, and people would get lost.
I
So
can put
so the thing that you'd want to do. So don't, not to pick on you, but the thing you'd want to do is learn these little techniques we're about to learn today, so we can substitute things in, and it makes this problem simplify down to a single trig function. Like, one of these is the answer. That's what it comes down to. And we have to learn the rules for doing it. Okay? Now, some people they can try to type this in, they can put parentheses and all that good stuff. But the problem is the calculator won't simplify, because I haven't put numbers in here yet. I haven't put in like 30 or 40 degrees, and we want to find the exact answer.
Does this apply in non-Euclidean geometry?
Yes. Yes.
Ooh.
It can apply to curves, it can apply to edges. That's why the last couple days we've been working with circular functions like the waves, so that we can apply them to three-dimensional objects.
We have to do more
This is
substitutions.
believable then.
What?
We have to do more substitutions, right?
No. Like this stuff will apply to it, but there's ways to like cheat it so we can like get
So
away
you're saying
from
there's
it.
no straight lines
So
in
we're
this?
never gonna graph those.
Straight lines aren't
Put your Johnny Hancock.
We're going to graph it for notes, but no. Okay, does that answer your question? All right, now, again, why are we doing this section? This is the number one thing that when kids go into Calc 1, Calc 2, they're in some upper level math class in college, they struggle at taking some problem and simplifying it down to something easier to look at. Because that, don't get me wrong, that is ugly to look at. It's got a lot of things going on, there's a lot of trig functions. Some people don't even know what those things are. You know, in the first place, you guys are pretty good because you had the background where you know what sine means, you know what cosine means. But some people don't. So simplifying these things down can actually make the problem easier to understand later, like what it actually is asking you for. Okay? So this is something we're going to try to end with today. And try to simplify this thing down to a single trig function, a single answer. Okay? All right. Now,
it's pluses.
we're going to come back to that one. That's kind of the goal in the end today.
Tangent.
All right. But what we need to start with today is the basic rules. What are rules for doing substitutions? What do we use? Like, what are these things? How do I know that they work? All that good stuff. Like, we're going to talk about today, like, why is tangent written like this? Why can I suddenly, instead of writing tangent, why can I put sine over cosine? Why does that even work? We're going to look at that today. We're going to look at why do these things equal each other? Why does cosecant mean the same thing as 1 over sine? That's what we're going to look at. And then we're going to start learning how to substitute these things in. We're going to start easy, work our way to more complicated. Okay, but we need to know the rules first. Okay, so we're in section 5.1. Okay, these are called the trig identities. Okay, hey. All right, so here's the rules. Okay, the basic rules that you need to have written down that we're going to kind of follow. Again, these are more like guidelines than they are like official, like strict rules. Like, you don't have to necessarily go in this exact order, but it does help. Number one, you want to replace all trig functions. Replace all trig functions with sine and cosine. So like in a very complicated problem, if you have tangents and cotangents and secant and cosecants, one of the rules that you might want to explore when we're doing our problems is to replace everything with sines and cosines. So as you can tell, there's certain things, like if I had a cosine or cosecant in a problem, I can replace it with 1 over sine. I can replace it with a fraction in the middle of the problem. I know that seems silly, like I'm going to make it more complicated for a few seconds, and then it will simplify later faster. We're going to see one of those in the first example we're going to do. The second type of rule that you want to look at, and again, these are in no particular order, I'm just giving you the basic rules. Number 2, you want to try to factor items apart. What I mean is, like, if you have a difference of squares, or you had a common factor that a lot of things have, and you'll see that in one of my examples. In fact, one of the examples I did earlier, there was a common factor that we're going to look at, that I wrote on the board. Okay? We'll look at how to factor items apart. The third rule that we always look at, that we try to use, you want to try to combine You want to try to combine fractions with common denominators. You want to combine things with common denominators. And then the final fourth rule that I usually follow, and again, these are no particular order, one of the fourth rules, which is something that I would have you use on that first example as well, is if all fails, you need to try to use a conjugate. Conjugate is an opposite of a denominator. So it's like if I give you a binomial, a conjugate is putting a negative sign in the middle of it. There are certain rules when you want to try to use that. But these are the four rules that I usually follow when I try to do these problems. Now, it's, the problem is with starting this for the first time ever, it can get frustrating, especially in the beginning when you first start, because you have to already have this understanding in your head that you are going to fail a few times on a problem, and you need to just restart it. Let's just wipe it, clear your mind, take a break for a little bit, and then try it a different way later. And try to simplify it. Because some of this stuff can get tricky. Like when I first started learning this, there was a lot of frustration trying to figure out what rules to use, how do I know what the answer is going to be in the end, and I'll try to show you kind of what you should expect. But these are like the first few baby steps today. So I'm going to try to break you in slowly into this so you get kind of a feel for it. Now, obviously, watching me do it's a lot different than you trying them out by yourself. So, like today, I'm going to show you kind of a scatter of different types of problems. Some are easy, some are difficult. And then tomorrow is more the hands-on day. Like tomorrow, I'll try to give you a couple easy ones in the beginning and try you to have them out. And we'll probably, like when you walk in tomorrow, I might have you in pods. And then when we start our activity tomorrow, we'll move from pod to pod and we'll try different types of problems. So like certain pods are easier than others, and we'll see if we can advance through the pods. Okay? But that's kind of the idea. So because it does take a lot of practice. Like this is not something that I'm expecting us to be great at in the beginning here. It's something that we need to build on for a while. Like it's not easy. And so don't feel frustrated. It's hard for almost everybody. So it's kind of one of those things like once you figure out the rule, then it gets a lot easier quickly. But you got to figure out like how to use these correctly and like what these mean. Okay? So I'm gonna leave this up here just for a few seconds. So if you haven't already, if you have your property sheet, make sure you box this in because these are going to be like the majority of the ones we're going to use. Probably these top two today. If we get a chance, I want to do these bottom ones, and then maybe as early as the end of the class or maybe tomorrow we'll look at this last one. But what I want to start with first is just start easy and talk about why do some of these things work. Like why can I use these to substitute? Okay, so here's the first one. I'm going to zoom in on this just so we can see this, and I'm going to try to cover it up. Okay. Alright, see if I can't really zoom any bigger than this. Alright, this is the first one I'd like to write down, is this one right here. It's tangent equals sine over cosine. Now I know it's on your property sheet, but I want you to write it down in your notes somewhere. This is going to be our first one. I'm going to talk about why does this work. Like I'm going to show you that it does, that they are equal to each other. But I'm going to try to show you an example why you'd want to use it. Okay? Does that make sense? Okay. Okay. All right. So first example here, I'm going to try to prove that tangent is equal to sine divided by cosine.
More Luther King would sign you this way. See, we all have the same number. It's all seniority.
Okay. Now, when we do this, I'm going to try to prove this. So this is not like a normal problem that you'd be using.
Attention, please. Jamie from Atletico is now ready to see any students or seniors that need to see
I
her.
heard you had a look.
All right. So goal here is I'm going to try to prove this. This is not a normal problem. I just want to show you that this first property does work, and then we're going to show you how to use it. All right. I want to try to show that tangent is the same answer. So if I had a right triangle in here, and I put some numbers down. So let's say this, we'll use the 30, 60, 90 triangle, right? 30, 60, 90, the side opposite of 60 is root 3, side opposite of 30 is 1, side opposite of 90 is 2. Let's just talk about what the tangent of 30 would be.
Your projector's having a heyday up there.
Yeah, it's been on most of the day, so we gotta turn it off.
I feel like it's gonna be
Lars gonna fix it.
You won't. Yeah, I can do it.
He knows what to do.
If you just blow on it.
Oh, stop. Just sit down.
It takes a couple minutes for it to travel there. Oh, listen to that.
See, look,
You
it worked.
Yep.
Alright, anyways, what does tangent mean?
Opposite?
Opposite over adjacent.
Okay, opposite over adjacent. Alright, so op over adjacent.
That
So,
freshman right equals
so
C.
this fraction, if I write tangent of 30, this means the opposite wall over the adjacent wall. Opposite of 30 degrees is the opposite wall is 1 over root 3. Okay, that's what it means. Now, if you want to simplify, it's root 3 over 3, it's fine. Okay, now, to prove the point that I would get the same exact answer if I did sine divided by cosine, I want to show you that. So if I chose, instead of doing theta, if I chose 30 and I did sine of 30 over cosine of 30, I want to show you that I would get the same answer. This answer right here. So what I'm trying to do here is to show you that the properties do work. The properties that are on that cheat sheet. And then we're going to show you how to use it. And what your homework problems would look like eventually.
Alright. Your name's
Okay, and what a problem would be on like a math placement test. Okay, we ready?
Yep.
Okay, alright. Sine of 30. Sine of 30 is opposite
Over.
over hypotenuse.
Dang it.
Okay, there's a lot of talking for not knowing what we're doing here today. Because I can just throw evil problems at you right now. And try to figure them out.
That would suck.
You have no idea until you get into it. So,
It would suck.
alright, so sine of 30. Sine of 30 is opposite, so I'm going to do the top, this is the top fraction. So it's the opposite over the hypotenuse. So it's half for the sine of 30, right? So the opposite wall is 1, the hypotenuse is 2. Now cosine of 30 is the adjacent over hypotenuse. And so we have two fractions. So if you're dividing fractions, we do have to do a reciprocal because you can't leave a fraction over a fraction. That's called an improper, or it's called a mixed, you know. So what we have to do is we have to divide by the bottom. So you're dividing by this, because that's technically what it is. That's a writing in colon form instead of fractional form instead of complex fraction. And we do the reciprocal like everyone's kind of saying. You flip it over, right? So you'd actually flip the bottom fraction over, and you multiply by it. So it's 2 over root 3. Now the reason why you do that is that this is the rule for how you divide fractions. You actually just multiply by the reciprocal of the second one. So you flip the second one over. Well, you guys are even saying, choose cancel. Like that's how it works. You simplify diagonally, and then you can just go straight across.
You're telling me that's what
you get
tangent would
1
have
over
been.
root
So what
3.
you were gonna say.
Well, I'm trying to show you here that this does give you the same answer. Now obviously one is simpler than the other. So if you had a problem where maybe you had sine over cosine when you're simplifying all these very complex, functions, you can eventually replace it with tangent. Because that would give you the same answer, and that's a simple trig function to work with. It's one single trig function, as opposed to doing two and doing extra work. So it does make problems easier. So we're trying to simplify a very complex problem down to make it easier to look at. Okay, and then maybe it's easier to even type in, or easier to just to actually write down in a fraction form. Because doing tangent of that triangle is actually really simple, as opposed to doing the whole complex thing. So that's why they want you to learn these backwards and forwards. Now, I want to show you how we would use it. So how would I do a problem like this? So let's say I had,
Thank you guys for joining the quality movement.
let's say that this is my problem. Tangent of beta times cosine of beta plus sine of beta. And, they gave me my number for beta, and let's say, off to the side they said beta was 45 degrees. Okay, you could plug the 45 in, you could type those all in, and you could figure out each answer separately and then try to add the fractions together and multiply fractions. It's complicated. But if you know these simple rules that I'm trying to show you, we can make this problem easier to look at before you start the problem. It simplifies the problem down to a single trig function, and you only have to do one trig function, and you have your answer. It's like it's quick, it's easy, it's simple. I wouldn't need a calculator in certain cases. Okay? So what you do, and this is like the weird rules, and you'll get to learn these eventually, and I'll plug a 45 into this problem here in a second. Where when you first start your problem, you just kind of have to have certain properties memorized. Like one of the properties, like, when I'm thinking about this list, replace anything in the problem with sines and cosines. So like on this problem, I want to replace tangent. I'm going to take tangent out and plug in the fraction I just showed you a little bit ago. Tangent is the same thing as sine over cosine. Sine of beta divided by cosine of beta.
Is the fish beta named after the beta?
No, probably not. Alright, so we have this, right? So I replace tangent with sine over cosine. That's what we said from that property sheet. Now, when you multiply, what happens to the cosines?
You cancel out.
Yeah, these would cancel because when you multiply, you simplify diagonally. So this would just be sine of beta
Times sine of beta.
plus sine of beta.
Plus sine of beta.
And this would, if you add these together, that's 2 sine
Sine
betas.
betas. Holy cow.
So that's an easier problem to do if I had my numbers. So maybe I was trying to find 45 degrees. That was the beta that I used earlier. Well, if I'm going to plug in the 45, now I can plug in 45 here. 2 sine of 45. And this number, whatever the sine of 45 is times 2, that's the same answer as this whole thing that we did earlier, which would have been more complicated. It would have been a way more difficult problem. So sine of 45, if I use that 45, 45, 90 triangle, 45, 45, 90,
Why don't we just plug that in?
that's 1, 1, root 2, which the sine of 45 is opposite over hypotenuse, so 1 over root 2 times 2, which if you write this as root 2 over 2, if you actually rationalize it, the 2's would actually cancel and your answer is just root 2. Like it's a simple answer and I didn't even need a calculator for it. Like it's a simple number, it's a digit.
Yeah, it's the same if you just plug it in.
Yeah. If you can figure out how to type these in, it eventually gives you the right answer. It does give you the same answer, but this is exact form. And maybe you didn't recognize the square root of 2 is 1.4. Yeah. Like maybe you didn't recognize that. Well, this gives you the exact answer for it. And it didn't take a lot of work. It was just simple steps, but you had to learn what to simplify, like what to plug in, what to cancels out, like the little rules that you had to think back to, like Algebra 1 days that you had to remember, okay, when you multiply fractions, certain things cancel. When you add, sines together, that's 2 sine, right? Because you're adding the leading coefficient. These are like variables when you add these together. So 1 plus 1, that makes 2. And then if you're going to plug in, you can solve it from there. Like there's like little rules you got to learn. But this is like the first baby steps today to see like why we would ever choose to do this. Because like I agree, like some cases like that, you could probably just type that in a calculator and it would probably give you the answer. You'd be probably mostly fine with it. But if you didn't have the luxury of a calculator, how could you find it out quickly? Simplifying. This would be a method I would probably choose like that. Okay, questions? Okay, now obviously that was like the first like little instance, like when you choose to substitute things in. Okay, so let's do another one. So so I want to show you kind of what we can do here. So now I'm gonna prove what the next one is, and then I'm gonna show you how we can use it. Okay, so cosecant of theta is 1 over sine theta. I want to show you why these are the same answer, and then we'll show you how you can use it in a problem.
Cosecant?
Okay, so on this particular problem, cosecant, let's say we're doing a triangle, let's say we're doing the 30, 60, 90 triangle again, I just like to use those. 30, 60, 90, the side opposite of 30 is 1, root 3 and 2. Alright, and let's say that we're doing 30, so I want to show you that the cosecant of 30 degrees is the same as 1 over sine 30. So this is how you could type it in your calculator. Like you could type in, instead of doing cosecant because you don't have that button, you could type in 1 divided by sine and that would give you the same answer. Then that'd be the actual answer for cosecant on your calculator. So that's a way of cheating. That's why they didn't need to include that button somewhere on your calculator. So how we could do this. So I want to show you that it is the same answer. So cosecant, it's the reciprocal of sine. So if we find the sine's answer, sine of 30, which is opposite over hypotenuse, so sine of 30 is 1/2. So the reciprocal of it is 2 over 1. So that's what this cosecant of 30 is. Well, sine of 30 is 1/2, like that. So it's 1 divided by half. And then you do that whole reciprocal idea, because it's 1 divided by half, where you'd flip it over, and you'd multiply it, and you get 2. So it does give you the same answer. It's 2 over 1, which is the final answer.
I like that.
Okay? It's simple, right? It's an easy little substitution rule that you can use, and it gives you the same answer, it's just one's quicker than the other. Because, even on like a little Casio, like that's kind of tough to type in, right? Because you have to go 1 divide, and then you have to type in sine of 30, which is not easy to type in originally anyway.
30
But then you got to make sure it's in parentheses.
30.
That's why you just get, you're up
So it's
to
1
it.
divided by 0.5.
Yeah,
two.
30, yeah,
So-
that's
All right, now let's talk about how I can use it. So let's say that my problem has something like this. Let's say it was,
I don't know. So where's the? I can't do that right now.
let's say it's
Somebody had a dog like
tangent
Casio, they put it to sleep. No, they wouldn't.
divided by
That's just
cosecant.
my fault. You make them. I'll make it better pictures.
All right, let's say that this is my problem.
You can make repetitions.
Okay, I'm going to start something easy. Okay, let's say that this is my problem to start with, and I want to figure out what the exact answer is. And let's say that they gave me my theta off to the side is, let's say the theta off to the side is 60 degrees. So, and I want to figure out the answer. Now again, some people can just type that in. Let's say we're using 60. So we could just type in the 60, type it in your calculator, hit enter, it gives you a crazy decimal across the screen. Or you could learn how to substitute things in to figure out what we can do here. Now maybe it won't simplify. Maybe this problem doesn't simplify. We'll see that. Maybe we can see that there's an easier way to do it. But let's take a look at this one. So what I usually do is I always replace things with sines and cosines. This is what you always do. So the top is a fraction. So it's sine divided by cosine. Right? That's what this top one is. The bottom one is 1 over sine. So I'm replacing things in terms of sines and cosines everywhere. Okay? That's the top, that's divided by the bottom. That's what they are, because that's the two parts we talked about today. I can do a reciprocal here. So I can do a reciprocal and actually multiply, so sine theta over cosine theta. And we're gonna divide by the bottom. And when you divide by the bottom, you can do the whole flip and reciprocal idea.
Then you cross some stuff out.
Not in this case. So
Oh, yeah.
nothing simplifies here,
Oh,
right? So diagonally nothing simplifies, but we can go straight
Two
across
signs.
and nope, you're multiplying.
Sine squared.
Sine squared.
Sine
Yep.
squared.
So this is sine squared theta over cosine. Well, that doesn't look any easier, but it is, because the idea here is that you know sine from the triangle. We know cosine. We don't have to do any tangents. We don't have to do any weird reciprocal rules. And all you do is you type in your answer and you just square the bottom and you divide by whatever, or you square the top and you divide by whatever the bottom is. And that might be easier for you to figure out by hand than the top one is, because maybe you get the top one wrong. They're going to give you the same answer anyway, but maybe it's easier to do the bottom instead because you're more comfortable with the bottom. Does that make sense? Like what you can do there?
Yeah.
It could be as easy as maybe you didn't want to do this whole cosecant rule. So maybe this isn't the route you want to do. Maybe you didn't like doing it this way. You could have stopped. Maybe instead of putting this here, maybe you just left it tangent on the top, divided by the bottom, right? And eventually this is tangent times sine. Maybe that's what you're more comfortable with. Because you could have just moved the bottom up and did the reciprocal of the bottom. And made it sine over 1 times tangent on the top. And this is the same answer. So maybe that's the route you want to do. So there's not one great way to do it, but it's whatever makes the problem easier for you to calculate later. So it's a way to substitute. Okay, there's certain problems that eventually we're going to start with where we're going to simplify them down to one simple trig function. There's certain problems like this where maybe you want to just stop when you can't go any further and you want to stop at an easy part where you can type it in or just evaluate it. Because I know like these very beginning ones like that some people like to think that's easy. Like you just find the sine of 60.
What is this? Oh,
I
I
got
know.
All right. Hey, last problem of the day. Here we go. I wanna show one of these extra properties that I kind of hinted at earlier. It's this one. Sine squared theta plus cosine squared theta. And I want to show what this thing will simplify into. Okay? This is one of the major properties in algebra. Okay? It's actually a major property in geometry as well. This thing actually has a name, and we're going to figure out what it actually equals here in a second. This is actually called a Pythagorean identity.
That's on here, isn't it?
Yep,
Yep. I bet you it equals 1.
it does. Now, we're going to talk about why. Okay, so this is a Pythagorean identity. It's a way of doing a math problem with Pythagorean theorem, and it proves what my final answer is. Okay, so what this is, sine squared of theta plus cosine squared. This can be for any angle. Let's just do it for 30 degrees. So sine squared of 30 degrees.
Sine squared.
Did you 30
Plus
degrees?
cosine squared of 30 degrees. And again, it can be any angle you want, but it will always equal one simple number. And I want to show you why this works. Okay, and then we're going to use it from now on. Okay. So how this works, if we do my special triangle, the 30, 60, 90 triangle, 30, 60, 90, the side opposite of 30 is 1, side opposite of 60 is root 3, the side opposite of 90 is 2. All right, the sine squared, so sine of 30 is 1/2, right? It's opposite over hypotenuse, and we're going to square it. Okay, so sine of 30 is 1/2 squared. Okay? Because sine of 30 is 1/2, and you're going to square it. Now, cosine of 30, and we're going to square that number. Cosine of 30 is root 3 over 2. And we're going to square that one. And my goal is to show you that it does make the number 1. So when you square fractions, you square the top and bottom. Square of 1 is 1, square of 2 is 4. When I square this, the radical sign will cancel out, and I'm going to square the bottom, which is 4. And when you add the two fractions together, you get 4 over 4, which is 1. And that's the Pythagorean identity. You're actually seeing it like a mini algebraic proof of it, showing that it does work on whatever angle you want to pick. I just picked 30 at random. But this thing, what we can use this for, this Pythagorean identity, knowing that no matter what angle you pick, the sine squared of an angle plus cosine squared of an angle will always make 1, no matter what the angle is. So in the middle of a problem, if there was some complicated thing where maybe they did something like this in the middle of your math problem, and we'll look at one of these tomorrow. If you had something like this in the middle of a problem, you can replace this with something from this formula to make it easier to look at. This is where the parts where factoring comes in, because I know that's like a different, this is a difference of squares, but I can also substitute Pythagorean identities in there. And that's something we're going to look at tomorrow, okay? Remember, tomorrow we're going to take a few more notes in the beginning, and then we're going to take the first baby steps into trying this out by yourself. We're going to start with some very easy problems, and then we're going to see if we can go to more complicated ones. And I'll show you kind of what I'm expecting to be able to do by the end of class.
We're gonna get our test back.
Yeah, that's kind of the goal. This game will probably review
Use of the Casio calculator.
as long as I get some people to actually
Casio
sit in.
calculator will not be.
If somebody proposed amendment to end the use of the Casio calculator,
It will not be reused.
Just like a little-
It's not gonna happen.
Somebody made a petition to end the use of the Casio. How about to end seniorities?
Some-
Now